Hello, Assalamu alaikum. I am Dr. Ansari Farzana W from Chemistry Department, J.A.T Arts Science and Commerce College, Malegaon. As we have seen in the previous section, a gravimetry analysis, electrogravimetry analysis. Now today we shall discuss about the thermal method of analysis of TYBSc Analytical Chemistry. Thermal method of analysis include group of technique in which change in physical property of material is measured as a function of temperature while the substance is subjected to a controlled temperature program. In thermal method of analysis, the change in physical property can be measured as a function of temperature or as a function of time. There are various types of thermal method of analysis. Here some listed type of the thermal method of analysis are thermogravimetry, derivative thermogravimetry, different thermal analysis, different scanning calorimeter, thermometric titrimetry, dynamic reflectant spectroscopy. These are the different type of thermal method of analysis. We shall discuss in detail about thermogravimetry analysis. Thermogravimetry analysis is closely resemble or it is similar to classical gravimetry analysis. Any process in which change in weight occur can be studied by thermogravimetry analysis. In thermogravimetry analysis, the substance under study is recorded. The weight of the substance is recorded as a function of time or temperature is the basis of thermogravimetry analysis. Weight of the substance is recorded as a function of time or as a function of temperature is called as thermogravimetry analysis, and generally change in weight takes place by loss of volatile component like water from the sample. The change in weight can be used for quantitative analysis, and the temperature at which the change in weight takes place can be used for qualitative analysis. There are three types of thermogravimetry analysis. The thermogravimetry analysis are of three types. First type is isothermal and static thermogravimetry analysis. In this technique, the sample weight is recorded as a function of time at constant temperature. When the weight of the substance is recorded as a function of time at constant temperature, at that time it is said to be isothermal and static thermogravimetry analysis. Quasi-static thermogravimetry analysis. In this technique, sample is heated to a constant weight at each of series of increase in temperature, and it is called as quasi-static thermogravimetry analysis. Dynamic thermogravimetry analysis. In this technique, the sample is heated in environment whose temperature change in linear manner. The weight of the substance is recorded as change in temperature linearly is called as dynamic thermogravimetry analysis. Instrumentation of thermogravimetry analysis. The basic requirement of thermogravimetry analysis is apparatus for heating, one for weighing. The apparatus that simultaneously heat the sample and monitor its weight is called as thermobalance. The weight is recorded with the help of the apparatus which is called as thermobalance. A thermobalance makes use of highly precise and sensitive microbalance. Various components of thermobalance are sample holder, recording balance, furnace temperature control, thermocouple, and recorder. Here is schematic diagram of the thermobalance. Thermobalance, here temperature sensor, and it consists of the various parts. In the center it is called as recorder and temperature sensor. Sample holder is above the recorder and it is covered with a furnace. furnace temperature program, atmosphere control, recording balance and balance control, etc. These are the different components of the thermobalance. Thermogravimetric curve. A thermogram is a plot of change in weight versus temperature or time is called as thermogravimetric curve or pyrolysis curve. This curve is obtained in this way. Here we see that temperature T1 and temperature T2. T1 indicate that the loss in weight from दैट टेम्परेचर टू T2 टेम्परेचर. ये जो स्लोप है वो स्लोप इंडिकेट करती है कि कितना वेट लॉस हुआ from that temperature to that temperature. Or straight line indicate that, horizontal straight line indicate that there is no change in weight. Slope indicate that change in weight, or horizontal line indicate that no change in weight. Thermal equation of thermogravimetry analysis. Thermogravimetry analysis की thermal equation है. The most commonly used thermal equation is proposed by Coates and Redfern. The equation derived by Coates and Redfern for calculation of energy activation frequency order of reaction is as follows. These are the reaction for thermal equation. The log of 1 minus 1 minus alpha raised to 1 minus n divided by t square into 1 minus n is equal to log of AR upon AE 1 minus 2 RT upon E minus E upon 2.303 for n is equal to 0, n is equal to 1 half, n is equal to 2 by 3, n is equal to 3 by 4, etc. And second equation is indicate for n is equal to 1, where W0, the terminology used in this equation indicate that W0 is nothing but initial weight of substance. W is the weight of substance at time t. WF is the final weight of substance after completion of the reaction. N is the order of reaction. A is the frequency factor. E is the energy of activation. R is equal to gas constant, and A is equal to heating rate in degree per minute. Factor which are affecting on thermogravimetric curve or pyrolysis curve. This curve is called as thermogravimetric curve or pyrolysis curve, and the factor which are affecting on this curve are of various type. The factor which affect the thermogravimetric curve can be classified into two groups. First group is called as instrumental factor, heating rate, furnace atmosphere. Instrumental factor which affect on the thermogravimetric curve. The thermogravimetric curve is also affected with the help of characteristic of the sample. These are the two main factors which are affecting on thermogravimetry analysis. Weight of the sample, particle size of the sample, heat of reaction, component of the sample, source of the sample, etc. Which are affecting slope हमें मिलना चाहिए, कर्व पैरालिसिस कर्व दिस टाइप की. लेकिन अगर टेम्परेचर में फ्लक्चुएशन होता है तो दिस टाइप की ग्राफ नहीं मिलती, बल्कि देयर इज सम डिपार्चर ऑब्टेन इन दिस ग्राफ. और सम टाइम द अप्स एंड डाउन्स आर ऑब्टेन इन दिस ग्राफ if the factors, that means temperature is changed, if the particle size is changed, if the balance is not placed in a perfect or uniform or a smooth surface, if the fluctuation in electricity is often, that means if the source of the sample are different, then compactness of the sample, etc. and etc. Application of thermogravimetry analysis. Thermogravimetry analysis are widely used for determination of purity and thermal stability of both primary and secondary standard used in volumetric analysis. Primary standard substance, secondary standard substance, that means standard substances की जो purity रहती है, which can be easily determined with the help of thermogravimetry analysis. Thermogravimetry analysis also determine the suitable ignition temperature. Ignition temperature, as we have seen in the previous temperature, if the precipitate are heated from 250 to 1200 degrees C, then that type of the drying of the PPT is called as ignition temperature, ignition of the PPT, and the temperature is called as ignition temperature, and that ignition temperature can be easily determined with the help of thermogrammetry analysis. Thermogrammetric analysis is also helpful for the determination of composition of complex mixture. It is also helpful for determination of correct drying temperature and the stability of various weighing form for the gravimetry analysis. The second type of the thermal method of analysis is differential thermal analysis. Differential thermal analysis is the analytical technique in which temperature difference between the sample and non-reactive reference material is monitored when the two substances are subjected to identical heating program. The thermal curve is plot of the difference in temperature between the sample and the reference as a function of temperature difference between the sample and the reference material when the sample does not undergo any chemical and physical change. This is the ideal curve for the differential thermogrammetry analysis or differential thermal analysis. Differential thermal analysis, this is the ideal curve. That means here some ups and downs are obtained. The upper curve indicate that exothermic peak and the lower curve indicate that endothermic peak. The heat during heating operation, if the heat is evolved, so upper peak is obtained. If heat is absorbed, lower peak is obtained. This is the simple instrument of the DTA, thermal differential thermal analysis. This is the simple instrumentation, schematic diagram of instrumentation used for the differential thermal analysis, and it is called as differential thermal analyzer. Differential thermal analyzer, it consists of recorder, it consists of the range control, it consists of the peak control, heat block, and cell assembly, etc. and etc. Thank you for watching.